Hello friends, in this session we are going to see how to plot data and get publication ready graphs, and for this we are going to use this data which is saved in CSV format, and I have opened that CSV file in Excel, and this has 4 variables: concentration, replication 1, replication 2, replication 3. And these variables are actually from an experiment called as polyphenol assay. It's a colorimetric assay to estimate the optical density of different concentrations of polyphenol. Okay. And these are replicate readings. This is first replicate, this is second replicate, and this is third replicate. Okay. Now this file we will import in RStudio. And for that, we need to set working directory so that we can import data from that directory. And here, that directory, we will import using the set working directory function. This is the function for that. And within that function, within the bracket, in inverted quote, we will put the path of our working directory. And that working directory is this data plot. And here the path is there in Windows. I will click that path. I will copy that path. Copy and bring that to R, and here between inverted quotes I will paste that and just change these backslashes to forward slashes, and when we run that, this run button, the working directory will be set. You can see that this is our working directory now. Okay. If you want to see working directory, then this getWD function is also there. Just run that and you will see in which working directory we are working. Okay. Now from this working directory, we will import our data file, which is this polyphenol assay data file. Okay. For that, we have to use function read CSV. Before that, we will give name where we want to save that file. df is equal to, I am assigning that CSV file, and using this read.csv function, again bracket, in inverted quote, we will put name of the file. I am importing data using this read.csv function. It will read the file. Okay, we will not go into much detail of this. Okay, just look at the arrangement of the file. In the first row, our headings are there. Right click the file name, rename, and copy that file name when it gets selected. Copy, okay, and bring that and paste that between these inverted quotes. Put .csv. This is extension of the file so that the file will get imported into data frame df. I will run this now. Now data frame has got imported. Now we will see what that data frame is, df. Okay, that data frame will get printed. Run this df. Data frame will get printed. All the data got imported properly as 4 variables. Here we need to understand that this is a data frame. Okay, data frame is a rectangular data structure where columns are variables and rows are observations. Okay. If you want to know more about it, then we can use summary of this data frame, df. Okay, summary function gives us summary, and this is the summary. Concentration, minimum concentration is 0, maximum concentration is 100, first quantile, median, then mean, it is 50, and third quantile is 75. For replication 1, replication 2, replication 3, the same summary is provided. If you want to know more what type of variable there are, we can use the function structure of df. Now this function is providing us, first line is, it's a data frame, 11 observations are there, and with 4 variables are there. And first variable is concentration, it's an integer type variable. The values are also provided. Replication 1, that it's a numeric variable. 0.05 is the first data value, and likewise. Replication 2, it's a numeric variable. Replication 3 also a numeric variable. Now we know that our data frame has only numeric variables, and these absorbance readings, replication 1, replication 2, replication 3, are spread across 3 columns. Now we'll move to data plotting. These are numeric variables, and because of that experiment, these are correlated with each other. Concentration and replication 1, replication 2, replication 3 are correlated with each other. Okay, if you want to still see whether those are actually correlated or not, you can use the plot function, plot in bracket that df. Okay, it will give us a multi-panel plot, and where you can see that positive correlation is there between concentration and these three replication variables. We want to have the publication ready plot to show this correlation. For that, we will require a package called as GGplot2. Okay, you can install that using Tools menu, install packages, and type here GGplot2. Okay, you can click here and click install, and it is saying that one or more of the packages to be updated are currently loaded. I was working here, therefore GGplot2 is loaded, and it is asking me whether to I want to restart R before installing this package or not. I will say no here, and if you are installing it first time, you don't have to say no, just click install. Okay, it will get installed, and GGplot2 has got installed. This GGplot2 can be installed using this command also, install.packages, and in this inverted quotes, put the name of the package, that is GGplot2, and click enter. Package will get installed. When we have installed it, therefore I will not install it again. To call functions of this, we need to have function library. Okay. So that GGplot2 will get loaded into memory library, and inside that we'll provide it GGplot2. We want to load GGplot2 in memory. All the functions from the GGplot2 package will be there in the memory. It's a very specialized package. It's a grammar of graphics. It provides function to get publication ready plots layer by layer, and we will see how the plot we will get. For that, we will require to call a function ggplot, and in bracket the first argument of the ggplot function is df or data frame, and name of our data frame is df, there df. Second argument will be separated by comma. Okay, in R functions, arguments are separated by commas. First data argument is there. Now we want to provide it axis, that x-axis and y-axis. For that, we need to use the function AES, that is aesthetic. AES is abbreviation for aesthetic, and you can see in that yellow box that x and y are the first two arguments. The x argument will be concentration, y argument will be replication 1. This time I'm plotting just one of those three variables, okay, to see the correlation. This concentration and replication, this type of plot I want to get by doing this. We will run this to see what happens. We have got this plot where our axes are there. X-axis is concentration, y-axis is replication 1, and the axis has been scaled from minimum to maximum. That the function is doing at the back end, that scaling thing. Okay, it is calculating the minimum, maximum, and it is dividing those into equidistant values. And for x-axis, that scale is there, y-axis, that scale is there, and it has taken the axis names also by default. This background, this grid color is also taken as default. Okay. Now we want to add the data, add the points there, to show the points there, and we have not specified which geometry, like point, box, histogram or something we want to plot. Okay, here we want to plot the geometry point, geom. Okay. Now we will run this function to see what we get, and we have got the plot. Okay. And now we want to add trend line or regression model to this plot, and for that I will use a function or layer called as Geom smooth, and at the back end it will calculate a regression model for that, and will put that model as a line on this plot. When we run that, we'll see here that model has been placed on the plot. Okay, and this is the lowest model. Okay, and therefore it is not a straight line. If you want that at straight line, we can add there method. Method is equal to ln. Okay, we'll get a straight line. Okay. Now I want this straight line to pass through 0. And for that, I want to specify a formula, because it's a colorimetric assay. It obeys Weir and Lambert's law. Therefore, the concentration of 0, concentration 0 shall have optical density 0 only. And here it is not. Here it is showing intercept. We want this to pass through 0. And for that, we will use the formula. We'll specify the formula here. Okay, that y is determined. This tilde is for determine, or y is dependent on x, and to remove the intercept we will put -1. Now the y-intercept will not be there. Okay, when we run that, you can see that line is passing through 0. Now we have got a plot. Now this plot we have to customize further so that it will become publication ready. For that I will just remove the background and like that we'll make it white or something. And for that predefined themes are there. Theme are the specifications to show non-data visual elements of the plot, like what color of background shall be there, whether the box shall be there to the plot or not, something that. Okay, for that I will use the theme, and note that I have put the plus mark here so that I can add the layer. And when I type first 3 letters, I will get the drop down list, and from this I will use this theme black and white and will run that. Now the theme black and white has been applied to the plot. That theme we can change to theme classic also, and you can see the effect. Various different themes are there. Just type the first few letters, you will get the drop down list of those themes, and theme of your choice you can use there. Okay. Here to this plot now we have to add different labels. We have to add title, subtitle, caption, x-axis. This is taken as default. The column heading or variable name is taken as default value of x-axis label. Okay, we'll change that and we'll specify labels using labs. And for that also we have added the plus sign after end of this previous line. Okay, don't put this plus at beginning of the line, it will not work. Okay, labs, and there I will put title is equal to, and that is estimation of polyphenol content. Okay, this is title. Now subtitle I will give, subtitle is equal to Violin Dennis method. This method I have used to do the experiment. Then caption will be there. Caption is equal to that. You can put caption, suitable caption, and I will just put a dummy caption here. Experiment conducted as biochemistry lab. Okay. And then we will just see what happens when we run this code. And you can see that these titles and captions are there. Title has slightly larger font size. It is aligned to the left. All these are by default. We have not specified those. For subtitle also font size is less. For this caption also font size is also specific. Okay. Now I will just bring it to new line by pressing enter key. And there X label I will specify. That is concentration of polyphenol in microgram per ml. Okay. Then Y I will put Y is equal to OD at 795 nanometer. Okay. And this also shall be in inverted code. Please remember that the titles which we are giving to the plot, labels which we are giving to the plot shall be in double quotes. Okay. And when we run that, and it is saying that unexpected symbol is there. Okay, here I forgot to put the comma. I will put the comma, and because of that, that error is there. Okay. Now, the x-axis label is there, y-axis label is there. This plot is sufficient for publication. If you don't want this gray error band, then also you can specify for that. In the Geoms smooth, because it's part of Geoms smooth, we will use there AC, standard error is equal to 0. That error band will not be there when we run that. Okay. This plot can be published. Okay. But the two columns which we have not specified there, which we have not visualized there. Okay. And if you want to visualize those, then we can add geom layer again. Geom point. Okay. Put the plus again. And to this geom point, we will specify y-axis, new y-axis. For that, y is equal to. And no, here we need to put AES, aesthetic. Okay. Y is equal to that rep2 we will put. And now this should look different than the first value. First values, that rep1 is shown in black. Here we will use a different color. Color is equal to red. Okay. When we run that, the second point will get plotted. And there is not much difference. Okay. Then we can have the next thing also, geom point. And for that, I will copy this code and will modify this code. I will paste that code here. AESY is equal to rep3. And color I will put as green. Okay. Now that smooth line is not there because I have not, and labels also got vanished because I have not put plus here. Okay, because of that, this code has not got connected to the earlier code. I will put that plus there. Code will get connected, and you can see all the specifications which we have specified there gets applied to the plot. I will run that. Now these specifications have got applied. But here we have not applied this smooth to these two values. Okay. For that, we need to specify AES for the smooth also. Okay. I will copy this and will put that here again plus and put that here again plus. Okay, here I will put the AES argument, copy this AES argument, put that here. Okay, here I will copy this AES argument, put that here. Okay. And color also, color is equal to red for this, and here also color is equal to green for this. Therefore, this will get added. But this code has become very larger and very complicated. Okay. This is because of our data is wide data. Okay. These absorbance readings are actually absorbance readings. This is just one unit. Replication 1 has absorbance, replication 2 has absorbance, replication 3 has also absorbance. We can combine these three into a single column. This absorbance readings will be in single column. Okay. Now I will show you how to do that. And for that, we have to prepare a long table. Okay. This is wide table where similar measurements are separated across three columns or different columns, many columns. Okay. In long table, these are collapsed in a single column where this replication 1, replication 2, replication 3 will be one column and their values will be in other column. Okay. We'll see that, and for that we have to install the package tidier, and we are going to use a function from tidier, install package tidier, okay, and run that. I have installed that, therefore I will not run. And you can install through tools, install packages also, and when this dialog box appears, just type tidier, okay, and select that, click install, package will get installed. And when you install the package, just call the library tidier, and we run that. Now functions of tidier are there with us. Now here we will put that data into new data frame, that is df long. This will be long data table. And when you see that data table, it will be clear why I call it as long one. And for that, we are going to use pivot longer function. Okay, and this is a very good function, and this tidier and other packages which we are going to use are actually workhorses of data analysts. Okay, data analysts are much dependent on these packages. These are very good, easy to use functions. And for pivot longer, the calls argument we have to specify calls, which columns we want to collapse or we want to gather together. And this second, third and fourth column, therefore we will put 2 and this double colon 2, 4, 2 to 4, okay, 2, 3 and 4. This is shortcut for that. And these columns will be gathered. Then names to, where column names will go. Column names will go to replication, REP. Okay, this will be new column and heading will be replication. Values also will be new column, values 2. And values will go to OD 795. Okay, and we will run that. Okay. Now it is asking that error is there, no applicable method, something like that. And by looking at this, I have understood that I have not put the data here. Okay. Therefore, I will put name of my data frame, that is df. df. I want to collapse the columns from the data frame df. I will run that. Okay. Now the data frame has been collapsed. Now wide data has been converted to long data, and we will see that. I will have copy pasted the name of that data file and we'll run that. Now you can see here this replication 1 of 0 concentration, OD is 0. Replication 2, OD is 0. Replication 3, OD is 0. This is for 0 concentration. All three replications are gathered together in a single column. Okay, here also these are gathered together in a single column, and likewise those other rows are also there. Total 33 rows will be there, because in each observation, in each column, 11 observations are there, and we have collapsed those three replications together. Therefore, total 33 observations are there in df long. Okay. And here you can see str of df underscore long, structure of df underscore long, and we'll run that. It's a table. Table is a very advanced data frame. 33 rows are there, 3 columns are there. First column is concentration, it's integer. Second column is replication, it is a character value. Replication is the character variable because character values are there. And OD795 is also a numeric variable, number are there, and 1 to 33 observations are there. Okay. Now this df long is very, very useful or very, very handy to plot the graph. Okay. For that, I will just use this code, copy and paste this code where I want, and just do some very little changes. Okay. Now here df I will replace with df long, so that this data frame will be there in the data, and concentration, and this replication 1 I will put here, and that y-axis will be actually OD 795 because OD values are there in this, and this replication 1 I will map to color. Okay, in aesthetics only I have mapped this variable replication 1 to color attribute. Okay, so that all these replications will have different colors. Okay, rep. And this color will be according to there. Then you can see here legend also appeared automatically. Okay, replication 1, replication 2, replication 3, replication 1 has red color. We don't have to specify this. Okay, this very large code we have summarized in a small code just by converting the data frame to df long, wide data frame to long data frame. Okay, now I want it to get labeled. I want this smooth also, and I want these labels also. I have copied those from the previous graph, and I will put using that plus sign there and paste that. Okay, plus sign shall be at the end. Okay, and in this geom smooth, I will remove this aesthetic. Okay, and I will remove this color also. And you can see that I have got the plot which I wanted. Okay, this plot is suitable for publication now. Okay. Many things can be done. You can have a regression model of that also. But these replicate readings we can represent by their averages also, by their means also. Okay. For that we need to calculate mean of each concentration, mean OD for each concentration. And for that I will use another function from package dplyr. And for that we need to install dot packages dplyr. Okay. And this shall be in inverted quote. And when we run that, package will get installed. I have installed it, I will not install it again. Or alternatively, you can install through tools menu also. Then just go there, call the library. Okay. In library, put the name of the package we want to call, that is dplyr, and call that. Okay, dplyr package is there. Now I will put here df summary because I want my data to be summarized in this df summary data frame, and there I will put the data first. Now a new concept I will introduce, that is piping. I am using two functions together, and so that output of one function shall be carried as input to the next function. For that first argument I will use that df long, and from this I want to have the data, and I will put the pipe there, and pipe I can put using this percent symbol, this greater than symbol, and percent symbol again. Okay. And there I will group this data frame using the group by function, group by. And this group by function is coming from this dplyr package. Okay. Group by, and I will group it by using concentration. Okay. All these three concentrations should be grouped together. Okay. Then I will pipe it again. And for that, I have used a keyboard shortcut, that is Control-Shift-M. Control-Shift-M. And there, I will put the summarize function. Okay, summarize function is also coming from dplyr. And there, I will put mean underscore OD 795 is equal to mean of OD 795. Okay. And when we run that, we'll get the summary table where concentration and mean values are there. Now this summary table we will plot. I will just copy this and will bring that here, paste the code, and this df long I will change with summary, and in very little time we can get the plot, concentration, Here just mean underscore OD795. Color, we don't have many different variables, categories, therefore color we will not use. And when we run that, we'll get the plot there. Okay. In very little efforts, we can get the plot. I will just show you the different other plot types also, which we can get from the same one. Okay. The categorical variable we have, and we will see what is the distribution of data in those categorical variables, and we will use for that the box plot. I will put here the same code, and here just I will change this color rep, and I will make this replication to the x-axis. Okay, replication is the x-axis, OD795, mean underscore OD795. df long I will convert to summary, df summary. Okay, I have just changed the data which I am going to use. A df summary I am going to use this time. This replication will be the x-axis, mean OD795 will be the y-axis, and color will be the replication. Or we can change that to fill also, but we will see with color. This geom smooth we don't require now, because for box plot geom smooth is not there. Okay, plus symbol is required at the end, and here I will put geom box plot. Okay, and when we run that, okay, don't know how to automatically, it is saying some error. df summary, aesthetic. Okay, that in df summary that is not there. df long we have to use. df long, replication, OD795 will be there, mean. This here only these three categorical values are there, or ref variable is there. Okay, and now when we change that, okay, the box plot will be calculated. Okay, and you can see that these three categories are exactly similar to each other. Their distribution is exactly similar to each other because these are three replicates of the same experiment. Okay, now I will change this box plot to Violin plot. Violin plot shows some different thing. Okay, box plot shows 5-point summary, minimum, maximum, first quantile, third quantile, and median. These values are there for this data. Now I want to change that to Violin plot. Just this box plot I will replace with Violin. Okay. And when we run that, you can see the Violin here. Okay. If you want to overlap points over those, you want to see the distribution of the points, then you can put that geom point, okay, and put the plus sign. Don't forget that plus sign and run the code. The geom points will be there. But these points are in straight line because those are mapped to their x variable, that is replication 1. Okay. Just I will change that point to jitter so that they will get separated from each other, and you can see a little distribution. This is just artificial separation of those. In replication 1, that is the distribution of points. Replication 2, this is the distribution of points. And in replication 3, this is the distribution of points. Okay. We can overlap many different geoms also together. We can overlap that box plot also. I will just copy this box plot here, and I will put that box plot there so that it will also get overlapped there. Okay. Much complicated. It is overplotting, not desirable thing. Yeah. But can be done, and here you can specify aesthetic colors also, fill also, something like that you can do, and much advanced customization can be done to this plot. I will remove the box plot because it's overplotting. Okay, I will run that again. Okay. And these plots are looking very good and are can be published. Okay. And this is how GGplot provide us very easy to use, very intuitive function to plot our data into beautiful graphs. And thank you for watching this video. If you have liked this video, please click the like button. Subscribe to my channel if you have not subscribed yet, and share this video with your friends, and watch my other videos also. Thank you. Thank you very much.